Before we move into learning about how to do conversions between different units, we want to do a quick review of two major topics, and that is exponents and a specific form of exponents known as scientific notation. Let's start by looking at what exponents mean. So 10 to the power of 2 is the same as 10 times 10, which is of course 100. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. So what does it mean when there's a negative number? If I give you 10 to the negative 1, that's the same as 1 divided by 10, or 0.1. If I give you 10 to the power of negative 2, now you would say that is 1 divided by 10 times 10, which is the same as 1 divided by 100, or 0.01. And of course 10 to the negative 3 would be 1 divided by 10 times 10 times 10, or 1 divided by 1,000, which is 0.001. And what happens if I want to go the other direction? Let's say I have the number 100. How do I write that in exponential form? We're going to take a 100, you're going to say that there's a decimal place at the end of the zeros, and in this case you're going to go back 1, 2, so that means that is equal to 1 times 10 to the 2. If it were 1,000, you're going to go back 3 spots because we want to go back so that we end up with the 1 in front. So it goes back 1, 2, 3, and we end up with 10 to the positive 3. On the other hand, if we have numbers that are less than 1, we're going to see a number like 0.1, 0.1. You're going to go forward 1 decimal place. Decimal is on the other side of the 1, and we get 1 times 10 to the negative 1. And if we look at 0.00001, we'll move the decimal point forward 1, 2, 3, 4, 5 spots so that it's on the other side of the 1, and that would give us 10 to the negative 5. Now let's look at scientific notation. Scientific notation allows us to express numbers other than 1 times 10, multiples. We're going to have multiples that have other numbers, like 2 times 10, or 1.6 times 10 to the power. And in scientific notation, it's very precise about how many numbers are in front of the decimal place, so that everybody is consistent. For correct scientific notation, then, there should be one number between 1 and 9 in front of the decimal place. The number of numbers following that can be any number, but there should be only one number in front of the decimal place, and that will be correct scientific notation. So for these examples, we had 1 times 10 to the 2, that one's fine. We have 2 times 10 to the negative 3, and that one is fine. But what about the 1.6 times 10 to the third? That one's fine too, because they each have just one number in front of the decimal. Now let's see how those numbers would be written in non-scientific notation. We'll start with 1 times 10 to the negative 2. As you know, that is the same as 1 divided by 10 times 10, and that was 0.01. For the 2 times 10 to the negative 3, that's going to be 2 divided by 10 times 10 times 10. And so that would be the same as 0.002. What about the 1.6 times 10 to the third? Well, that is going to be the same as 1.6 times 10 times 10 times 10, or 1.6 times 1,000, which of course is 1,600. Now let's go the other way. So what if I have the number 463? What is that in scientific notation? Well, you're going to move the decimal back 1, 2, and you will get 4.63, and then it'll be times 10 to the positive 2. And if I have a number like 0.000496, that would become 4.96 times 10 to the negative 4. This section on exponents and scientific notation may help you a little with your mastering chemistry homework. This is also a good place for you to review the use of your calculator, make sure that you're ready to use it. And so you may want to also review how to do exponents using the powers of 10 on your calculator. There is a small video in our Canvas site that will review that for you. Here I've given you a few problems to try. For the first question, decide which of the following are in correct scientific notation. You should pause the video while you're going through these. Letter A is not correct scientific notation because we have 2 numbers in front of the decimal place. So this is not correct. Pause the video to do part B. Letter B is correct, even though there's no decimal place shown here. There is a whole number that would be in front of a decimal place if it were shown. Pause the video for C. Part C is incorrect because we can see that there is no whole number in front of the decimal place. We see just a 0 there. And it has to be a number between 1 and including 9, but not 10. Pause the video for part D. Letter D is incorrect because we do not have a whole number in front of the decimal place. Pause for E. And here we see that letter E is correct. In part 2, you're asked to write the following in standard notation. Please pause the video for answer A. I'm going to rewrite the numbers so that I have somewhere to work to show the work. Since the exponent is a negative 3, that means that our answer will be something that is smaller than 1, and so we're going to be going backwards with our decimal point. We're going to have to add some zeros in as placeholders, and we will find our answer after we go back 1, 2, 3 spaces is 0.004790. Pause for letter B. Again, I'm going to rewrite the number so I have space to write in zeros. In this case, we see that the exponent is larger than 1, and so we see that the answer will be a larger number. We know that this number is going to get larger, so I'm going to add some placeholder zeros in this case. And then we're going to move that decimal over 1, 2, 3, 4, 5, and 6. And we get our answer of 7369000. For part 3, you are asked to write the answers in correct scientific notation. Pause the video while you work on letter C. To write it in correct scientific notation, we'll find out where the decimal currently is. Then we're going to place it so that there is one number in front of the decimal place. We're going to go back 1, 2, 3, 4, 5, 6 places. So our answer will be 5.742689 times 10 to the power of 6. Pause the video while you do letter D. For this one, we're going to find our decimal place, and we're going to place it so that there is one number in front of the decimal, which means we're going to go forward 1, 2, 3, 4, 5, and 6. So our answer will be 5.6 times 10 to the negative 6. Notice that the number is less than 1, so we're going to get a negative number in our exponent. Also notice that I don't always keep those zeros. Those are just placeholder zeros because they're in front of an important number. Pause the video while you try part E. For this one, I know that I'm going to get a positive number in the exponent because this number is larger than 1. And so we're going to go back from the decimal place. We're going to go back 1, 2, 3, so that only the 7 is in front of the decimal. And that means that our answer will now be 7.856654 times 10 to the power of 3. How did you do? If you got some wrong, you might want to go back and try it again, or look up on the internet. You can look for scientific notation. I've decided to add in two more questions. So number 4, will the exponent be positive or negative? Please try A through D. Go ahead and pause the video and then restart it when you've done all 4. Hopefully you can see that in letter A, the exponent will be a negative number because this number is less than 1. Letter B will be a positive exponent because it's greater than 1. Letter C will also be a positive exponent because the number is greater than 1. And letter D will be a negative exponent because the number is less than 1. And let's look at number 5, which asks, will the answer be greater than or less than the number 1? Go ahead and pause the video while you do E and F, and then turn it back on when you are done. Hopefully, after the last part, you can see that if the exponent is negative, the answer will be less than 1, which is what we see for letter E. The answer should be less than 1. And for letter F, because that number is a positive number in the exponent, that answer will be greater than 1. Hopefully that'll help you to understand the ranges of numbers when you see these exponents, what's more positive, what's larger, what's smaller. In the next video, we're going to do some simple one-step unit conversions.